So let's solve this question. This question is 20 ml of each of oxygen and hydrogen and 10 ml of carbon monoxide are exploded in an enclosure. What will be the volume of composition of the mixture of the gases when they are cooled to room temperature? The first question is first we're getting on this question that we are having 20 ml of oxygen and hydrogen both. Okay, so 20 ml of oxygen, 20 ml of hydrogen, and we have 10 ml of carbon monoxide, that is 10 ml of CO. Okay, are exploded. What is the meaning of exploded means a reaction with oxygen. That means hydrogen and carbon monoxide both are reacting with oxygen, so we have to write down the chemical equation of those. Okay, and they are asking us volume of composition of the mixture of gases when they are cooled to room temperature. Okay, so let's see. So first we have to write down the chemical equations of reaction of hydrogen with oxygen and carbon monoxide with the oxygen. So first let's write down hydrogen plus oxygen. So when H2 reacts with O2, it forms, yes, H2O, right? So hydrogen is balanced but oxygen is not, because we have only one oxygen over here and here we have two oxygen. So we'll multiply this by 2. So now we have oxygen balance but the hydrogen is not balanced, so we multiply 2 here, so we'll get the balanced chemical equation. Now they have stated that we have 20 ml of hydrogen. Okay, according to Lussac law, all gases bear the simple whole number ratio, that is this. Now we have 20 ml of hydrogen, so we have 20 ml of hydrogen overall. Okay, so 2 into 10 gives us 20, so we write down this over here. So now if we write down hydrogen to oxygen, so if 2 moles of hydrogens are reacting, 2 volumes of hydrogen is reacting with 1 volume of oxygen, then 20 volume of oxygen would require X. Then X will be 20 into 1 divided by 2, which would be 10 ml. Okay, so for this reaction 10 ml of oxygen would be required. So overall we had 20 ml of oxygen. If we subtract 10 ml of oxygen from this reaction, remaining is 10 ml still. Okay, also why we are not calculating the volume of H2O, because it would be in the form of steam, but at room temperature it is asked when they are cooled to room temperature, and room temperature it would not be in the steam form but it would be in the liquid form, so we do not have to search the volume of H2O, right? Next reaction, when CO reacts with O2, it forms CO2. Again we have to balance the chemical equation, so we'll balance it by multiplying 2 over here and 2 over here. 2 carbon, 2 carbon, 2 oxygen plus 2 oxygen, 4 oxygen, 2 to the 4 oxygen. The chemical equation is balanced. Again according to Lussac law, the gases bears the simple whole number ratio, so we'll multiply here over this. Okay, it's asking now we have 10 ml of CO. Okay, so if we have overall 10 ml of CO, that means here 2 5s are 10, so here also 5 and here also 5. Okay, so let's write down that if CO to CO2, so if we have 10, if 2 volume of CO reacting to give 2 volume of CO2, then 10 ml of CO will react to give X ml of CO2. So again value of X would be 2 into 10 divided by 2, 2 into 10 divided by 2, so it would give us 10 ml. Okay, 2 5s are 10 ml. Okay, so how much carbon dioxide is formed? CO2 is 10 ml. Okay, 10 ml CO2 is formed. Okay, how much oxygen is being used in this chemical equation? Okay, so let's see that CO to O2, that 2 CO is reacting with 1 O2 to form 2 CO2, then 10 ml of CO will react with how much oxygen to give us 2 CO2. So again it's simple, find the value of X. 10 into 1 divided by 2, so 10 into 1 divided by 2 would give us 5 ml of oxygen. So it's very simple, we can directly write down, we get to know the answer from here only, but as we have to show the equations and the steps, we would write like this. Okay, so first, okay, so 20 ml of oxygen was used previously. So after it remained 10, from 10, 5 ml of oxygen again reacted. So 5 ml of oxygen is left behind. So 5 ml of oxygen left and 10 ml of CO2 is formed. So finally we can write down, if they are asking us the volume and composition of the mixture of gases when they are cooled to room temperature. So it would be 5 ml of O2 and 10 ml of CO2 are left.